Our answer key for the practice test, get right down to business. Given the following graph of f of x, okay, so this is the function f of x. Sketch the derivative, f prime of x, on the same grid. All right, well, the derivative, as we've been over and over and over, is just the slope of the tangent line at any particular point. So the slope right here is going to be 0, so our derivative will go through right there. The slope right here will be derivative, so it's going to pass through here. The slope is steeply positive, so it's going to be somewhere positive here. It's steeply negative, so it'll be down here in this area, and then it's steeply positive here. So it's basically going to come down, turn around, and go back up. At this point, I'm going to estimate the slope to be about -3 and sketch what is going to be very close to a parabola. All right, it looks like this is a third-degree equation, and as we've talked about it, the function of the derivative will go down a degree, so it's going to be something similar to this. All right, so there you go on that first one. Next one then, identify which graph is the function, the derivative, and the second derivative. All right, well, going in reverse, for instance, I see right off the bat, I'm looking for 0 slopes right here. For this one is going to be 0. It looks like that's that one right there. So if this function takes becomes this as the derivative, it should be consistent. Here is a pretty consistently negative constant slope of about -3, so it's down here. So that looks pretty good. So that would make A equal to B prime. If I take this and find the derivative, I'm getting this function here. Well, what happens next? It looks like this function here is positive, and I don't see anything up here that's positive. Well, it's still positive here, and yeah, it can't be this one because at this moment here as it turns, this is a positive slope, but this is still negative. So it looks like this one that has the negative slope here is negative. It's still negative. Here it's a 0 slope and it becomes 0. Here it turns positive. So this one, when you take the derivative, becomes the other one. So that means that C is equal to A prime. So that would make this be the original function f. This would be f prime, and this one would be here f double prime of x. Okay, so that would make, if you want to answer it this way, f is B, f prime is A, and f double prime is C. All right, so BAC. All right, move. Okay, on to the second page here. We're given the graph of f of x. So this is the graph of the derivative. I'm just going to label that to make it clear because sometimes it's easy to forget. And they're asking questions about the original function, not this one. All right, so what I think I'm going to do is go right down here to the last part where they say sketch a possible graph of the original function in the grid below, and then they're telling us that this function at 0 goes through the origin, and then they want us to mark all local max minimums and all that. So if I carefully sketch the original function here, it goes down, turns around, passes through 3.5 here, and does the reverse coming down. So you can judge my artistic ability here, but that's the original, and I've sketched it right there. All right. Now, that's the original, that's the derivative. So the original function then has got a 0 right here at 3.5. It's got a 0 right there at x equals 0, and it's got another 0 there at -3.5 for x. So I know that it's going to be an area where there's a local minimum or a local maximum. Again, there'll be a local minimum or a local maximum, and this one I know must go through the origin. And again, below here, there's going to be a local minimum and a local maximum. Well, I also know that the derivative here is positive, right? So less than 3.5, my original function has a positive slope. So it's got to be aiming up to get to this. So that's going to be a relative maximum point there. Then it's going to go down and be a relative minimum, and then it'll have to be a relative maximum again here at 3.5. So a possible function is something like this. And let's see what else then we need to consider. I think we're pretty good there. If we go back up to the top and start answering questions, we'll maybe come down and have another shot at it at the end. So where is f increasing or decreasing? Well, the original function here is going to be increasing until it gets to this place where the slope is 0. So that's -3. I should label this -2. That's +2, +3, +4, and -4 right there. So it's going to increase. I'm just going to sketch this in. It's going to increase until it gets right here to -3.5. Then it's going to turn around and decrease and come through the origin. And then again, it's going to go back up and increase until it gets to about 3.5 and then decrease. So that's one possible, again, one possible sketch for that function, the original function f of x. Okay, so then where is f increasing or decreasing? Well, it's going to be increasing, and I'm just going to do it here in interval notation, from negative infinity. It increases till it gets to -3.5, and then it decreases until 0, and then from 0 to +3.5 the function is increasing right there. Where is it decreasing? It's decreasing then from -3.5 to 0, and from 3.5 to -infinity. All right. At what values does the function f have a local max or local min? Well, those are the zeros. So it's going to be right there. It'll be right there, and right there. So that is it'll have a, let's say, a local maximum at x equals plus or minus 3.5, and a local minimum at x equals 0. All right. Where is f concave up or concave down? Well, that's a good time to consider this original derivative, because if we take the second derivative, we know that where the slope is positive, it's concave up, and where the slope is negative, it's concave down. So if I take the derivative of this function now, that's a negative slope, then it turns around and becomes 0 right here. So it's going to be negative until it gets to 0, and then it's going to be positive until it gets to this 0. So it's going to get positive and turn around. So this is a lot like the first problem on the first page. So this is my f double prime of x sketch. So it's really saying, where is this slope positive? That's from -2 to +2. So it's concave up here over the interval -2 to +2. It's concave down from -infinity to -2. That's concave down. And from +2 to +infinity. I could have been clever and used a plus or minus and an absolute value, but I'm going to stick to keeping it simple. And then let's see if that's true down here. It should be concave up in this area, so concave up. That would maybe help my graph a little bit. And then there's an inflection point where it turns around above 2, and then I should show it turning around and from -2 on. So mark all local maximum, local minimum. So I can write this as -3.5, and I can just make some value. I don't know, call it 1.2. A local minimum, that's a max. A local minimum would be at 0, 0. And then again another one at 3.5, and then call that 2. These do not really count for much. And inflection points, inflection point then would be at x equal 2. I'm going to try to make that clear, and at -2. And again, that comes from our concept of here, an inflection point is going to be when the second derivative has a 0. That's where it's going to turn around and stop decreasing and start increasing as the slope. All right, I hope that's straightforward. On to the next page.